In this tutorial, we will be discussing addition reactions. In alkenes and alkynes, the double bonds are very reactive. Adding H2, and water to the carbons in the double or triple bonds can reduce the number of bonds there. It's easily broken and provided the electrons for the new bonds. So here, when the hydrogen is added, it needs a catalyst of platinum, nickel, or palladium, and it produces an alkane. So basically it just breaks the double or triple bond and forms a single bond. With hydration, we're adding it with water, which becomes HOH, which is where that comes from. And because of that OH here, becomes an alcohol. Let's look at hydrogenation first. You remember what each reaction is just simply by looking at the word. Hydrogen is actually in the word. That's a key right there to know that you're adding hydrogen. Here's that catalyst right here. So essentially this bond is broken. It attaches to the hydrogen. We could actually write this like this. It might be a little bit easier to follow. So the bond's broken, attaches to that hydrogen. Then that electron goes around and it comes back around. Notice that was a double bond and now it's a single bond. If you have a triple bond there, it goes through this process twice, but it still forms that single bond. Alright, so write an equation for the hydrogenation of 1-butene using a platinum catalyst. Once again, it's very common for beginning students to get worried when they don't see an actual equation there. They're used to having it handed to them, and then they just try to manipulate it. Giving it in a word form is completely normal, and it's completely normal to be a little bit scared. Just know and believe in yourself that you know what to do. First thing we need to do is figure out what compounds there are. 1-butene. So that means I have 4 carbons, because but is 4. And on the first carbon is a double bond. Hydrogenation means we're adding hydrogen. It has a platinum catalyst. And that double bond here is broken and is replaced with more hydrogens. So it actually forms butane. I didn't write in the hydrogens here because I was getting lazy. Hydrogenation of oils is used very commonly to make things such as margarine. So here is an olive oil. They've taken this double bond here and they've gone through hydrogenation. And you notice that double bond's not there anymore. When you actually go to the grocery store, you'll see the word hydrogenation on some packages, because that's how the margarine is formed. Let's do another one. Once again, we have H2 with a double bond. So we have 1, 2, 3, 4 carbons. So we're going to have 4 carbons again. The double bond was here, so that means the new hydrogens are going to be right here. If we want, we can fill in the rest of these hydrogens, at least in the shorthand form, the condensed form. Alright, even if it's a cyclical compound, it doesn't matter. You're still going to break that double bond. So instead, it's going to look like this, with no double line there. Hydration is very similar to it. There are a couple of things you do have to remember. So hydration, just as if you were working out or you're in the sun, when you hydrate, you have water. You add water to it. That's what we're doing here. The water breaks down to HOH, and they do it this way so that way you can see where the bonds are actually formed and what atoms go together. So the electrons go to the hydrogen, which go to the OH, which come back. And that's how you get the alcohol. One thing to remember, the OH group goes to the carbon with the fewer hydrogens. So when you're given a chance right here, they both have 2 hydrogens on either side. If you're given an option where one has more hydrogens than the other, the OH will always go with the one with the least amount of hydrogens. Alright, so here we have the H and OH. 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. So we have an option of here and here. The OH group is going to go on this side, on the left-hand side. They have the same amount of hydrogens, but this one has more carbons coming off of it. That's why I put it over there. On this one, notice that the last carbon has 2 hydrogens coming off of it rather than just 1. That's going to impact greatly where that OH lies. So we have 4 carbons. That OH is going to go on the furthest one out. So that becomes an CH3 rather than a CH2. And that's how you do addition reactions.